students, in previous lecture we have studied unguided media. And unguided media means what? The information or data can be transmitted without any wire. So how data is transmitted then? Data is transmitted as an electromagnetic signal. Okay. So those electromagnetic signals, they travel in a media. In a media means in atmosphere. Clear? There is no any hardware media. There is no any device media. They use atmosphere to transmit. Clear? So in unguided media we use some types of propagations here, and those we are going to study. So in previous lecture already I have told you, radio wave, microwave and infrared light, such unguided media, they use different types of propagations. Propagations means to transmit data, they use different types, and those types we are going to study in today's lecture. So there are three types of propagation. First one is ground wave propagation. Second one is skywave propagation. Third one is line of sight propagation. So let us study one by one. Before that, propagation means what? Propagation means transmitting the data from transmitter to receiver. So this process we call as propagating the data, means transmitting the data. And unguided media uses some types of propagation, so that we are going to study. So first one is ground wave propagation. So this ground wave propagation is used by the radio waves. So the radio waves, to transmit their data, they use ground wave propagation. Means how radio waves are transmitted using a ground wave propagation. Then microwave, how microwaves are transmitted using skywave propagation. And sometimes line of sight propagation also, based on the microwave range. Then third one is infrared light, and that infrared light uses line of sight propagation. Okay. So before moving to the more detail about types of propagation, you should remind the examples for radio wave, microwave and infrared light that I have explained in previous lecture. Students, for better understanding, keep watching each video of every subject. Okay, it is very important for your exam. So what is the example for radio wave is FM radios and television channels. There we use radio waves. Then what is the example for microwave? So example for microwave is wireless LAN. Wireless LAN is the example for microwave, and also cellular telephones, means cell phones and satellite networks. Okay, so these microwaves, these are the applications of microwave, means where we can use the microwave. Clear? Then infrared light. So what is the example for infrared light? Try to remind it. You use that daily. So that is television remote. So whatever waves transmit from remote to television to change your channel or to change the volume, such waves are nothing but what? Infrared light waves. Clear? And why I am telling you to remind the examples for radio wave, microwave and infrared light is, based on example you can understand what is ground wave propagation, what is sky wave and what is line of sight. So now we move to the first one, that is ground wave propagation. So here in ground wave propagation, the wave propagates through the Earth's atmosphere, and that is why they are called as ground wave propagation, and it is used for transmitting low frequency. It is used to transmit low frequency signals. So in this propagation, the signal wave is always parallel to the ground. So now let us see how the ground wave propagation looks like. So this is first diagram you can see. So that is what? Ground propagation. So now at what is displayed as this circle or sphere, that is nothing but Earth. So whatever displayed with a dotted line, that means the ground waves that travel through the Earth's wall. Clear? And there they have shown one antenna. So that antenna can transmit waves through the ground, means through the earth walls, but in parallel manner. Always the ground wave propagation propagates waves in parallel with earth surface. Okay. So now let us see how it will transmit. Okay, one more point you have to see here. This is what? Ionosphere. So you can see here ionosphere is mentioned. So ionosphere means what? That also I will tell you. So now see here, consider this is the earth. Okay, consider this is the earth. So whatever area surrounding earth, that area we call as ionosphere. So that we call as what? Ionosphere. Okay, why we call like that? Because from sun, the earth receives sun rays. So those rays we call as cosmic rays. Those rays we call as cosmic rays. Okay. Then when sunlight reaches to earth, when sunlight reaches to earth, what happen is, consider this is the sun ray coming from sun and it is traveling towards the earth. So when this cosmic ray enter into earth sphere, what happen is, here already some density will be there. Density means some air or some atmosphere will be there. So that atmosphere is consisting of small atoms. Are you understanding? In that density, small atoms will present. So now when sun ray strike with that atom, what happen is, from that atom the electron will get eject. The electron will get eject. Means electron is removed when cosmic ray enters or strikes the atom from atmosphere. Are you clear? Okay, now that electron we call as ion, and this process we call as ionization. So ionization means cosmic ray get strike to the atom in the atmosphere, and from that atom electron will get ejected, and that is called as ion, and this process is called as ionization. So that is why this complete area we call as ionosphere. Are you getting? We call it as ionosphere. Okay, now consider, okay, come to ground wave propagation now. Consider this is the earth, okay, and consider this is the ionosphere of earth, okay, and now how ground wave travels. So consider this is the antenna, clear, and this antenna is sending some data as an electromagnetic wave, and which electromagnetic wave is traveling here? Radio wave, okay, because ground wave propagation means always waves travel through the walls of earth. Why through the walls of earth? Why not away from earth? Because these waves always consisting of low frequency. If high frequency wave is there, then that can travel like this, okay, but low frequency wave means that will travel always through the ground wall of earth. Understood? Okay, now because of that, the ground wave propagation means waves are traveling through the earth wall, means they can penetrate through earth wall. Clear? Okay, now next characteristic is the ground wave. In ground wave propagation, always waves are parallel to ground. Always waves are parallel to ground. Okay, consider this is the first antenna and consider this is the second antenna here. Okay, now if wave is traveling like this, then it can reach from first antenna to second antenna because parallel is possible. Parallel propagation is possible. Okay, so consider first antenna is here and consider second antenna is here. Okay, then if you are transmitting a data from first antenna to second antenna, then using ground wave propagation it is not possible. Why? Because in ground wave propagation always waves are with low frequency, so they are traveling through the ground part of earth. Okay, now is it possible to transmit the data wave from first antenna to second antenna in parallel way? No. Why? Because of curvature nature of earth. Earth is curved in dimension, so we cannot transmit the ray or wave in parallel from this first antenna to this second antenna, because if you start transmitting in parallel, then you get walls here, walls of earth, so you cannot transmit within the earth. Your wave should be transmitted through the outside of earth, and in that case, in our example, parallel transmission is not possible. Clear? So that is why using ground wave propagation, the propagation is very short range. Understood why? Because of parallel transmission. So as we have increased the range here, distance we have increased, it is not possible because parallel transmission is not possible here. Understood? Okay, now come to skywave propagation. So in skywave propagation, let us see how it looks. So this is what? Skywave propagation. So in skywave propagation, they have shown it using two antennas and with ionosphere. So I will explain you what is skywave propagation now. Okay, now again consider this is the earth and consider this is the ionosphere of earth. Okay. Okay, now consider first antenna is here and consider second antenna is here. Okay, then this first antenna is transmitting the wave. Okay, so in skywave propagation, the waves are not in low frequency. The waves may be with medium frequency or they may be with high frequency. So whenever in sky propagation, whenever first antenna transmits the wave, that wave gets reflected by the ionosphere, and then because of that reflection, that wave reaches to second antenna. Are you clear? Okay, if not, once again I will explain you. Consider this is antenna 1. Consider this is antenna 2. So now antenna 1 transmits the wave and that wave reaches to atom and it will get reflect, and because of that reflection it reaches to second antenna. Understood? Any doubt here? So this is what skywave propagation. Then now see what is the advantages of skywave propagation over ground wave propagation. So in ground wave propagation, what happen is, if this is the earth and if here is first antenna and here is second antenna, then propagation is possible because parallelly we can transmit. If this is the first antenna and this is the second antenna, then in ground wave propagation, propagation is not possible because parallelly we cannot transmit. Clear? Okay, now come to skywave. So in skywave propagation, if this is the earth and this is the first antenna and this is the second antenna, then this first antenna will transmit the data, it gets reflect and it reaches to second tower, or we can say it as second tower also we can call it as, or second antenna. Clear? Okay, now consider this is the first antenna and consider here is the second antenna. Okay, so now first antenna will transmit the wave and that is high frequency wave, so it reaches to long distance and at that point it may get reflect, and from that point because of reflection it may receive to the second antenna. Understood? So long distance transmission is possible in skywave propagation, but in ground wave propagation only short distance transmission or propagation is possible. Understood? Okay. Then short distance. Ground wave propagation provides short distance. So example is radio channel. So here in Belgaum district, I can't say, in Sankeshwar we can hear to the radio channels like FM 96.3 or 93.3, like few channels. Okay, can we hear Mysore radio channel or Bangalore radio channel like Radio Mirchi and all here? No, because their range is short. They cannot reach long distance. Okay, so that is why we cannot access such radio waves, means such radio channels. Understood? So radio waves, so what point you have to remember now is radio waves uses ground wave propagation. Ground wave propagation means the frequencies is with, the waves are with low frequency. Because of low frequency, they travel through the earth wall, and in ground wave propagation, the propagation is always in parallel to earth, and because of earth's curvature nature, we cannot transmit long distance. Parallel transmission is not possible. So that is why radio channels can be listened only in particular area. Long distance channel cannot be accessed. Clear? The next one is skywave propagation. So it can be used for any distance. So that is why we can say the example as cell phones. So cell phones you can travel any distance. Okay. So you may ask question as, sometimes we may not get network for our mobiles also. So that is because of whatever company you are using to attach with. Means Airtel have ranging all over India. Why? Because Airtel company have many antennas, means many satellite antennas they have fixed in many area. Means almost all India they have covered compared to Vodafone and others. Clear? So that is how, based on range, our network, means our mobile network works. Okay, then come to third one. So that is that is line of sight propagation. So line of sight propagation looks like this. So easily you can understand here only. Line of sight, name itself indicates. So where the waves can be transmitted in the line of sight is from one antenna to another antenna. So this is the first antenna and this is the second antenna. So both antennas are at the point such that they can see each other. Sight means what? Watching. Okay, we can say my sight is till this extent, means I can watch till that extent, like that. So here both antennas are at sight of each other, means they can watch each other, they can see each other. Okay, so line of sight means they transmit in one single line. Okay, Okay, now consider one first antenna is here and second antenna is here. So whether first antenna is at site of second antenna? No, because of Earth's curvature nature. Because of this curve, this first antenna may not be in the site of second antenna. In that case, we cannot transmit the information. That transmission is not possible. Understood? Okay, now example. What is the example? Where we use line of sight propagation? In infrared light. Clear? So infrared light, where we use? What is the application? Example. So example is TV remote control. So can you operate your TV by standing in another room? Means by standing in the room where TV is not exist? No. Means can you operate your TV channel or TV by using your remote with the in between wall? No. Because there is no line of sight propagation if you try to do that. Clear? So this is how the three types of propagations are available, that is ground wave, skywave and line of sight. Hope you have understood everything. Thank you.